Hey students, in this video we're going to cover applications of conic sections. So let's get started. For number one, we have a giant wheel at an amusement park. The diameter of the wheel is 128 feet. And it sits on an 8-foot tall platform that makes the total height 136 feet. We need to find an equation for the wheel, assuming that its center lies on the y-axis and the ground is the x-axis. So that gives us somewhere to start. I've already included a drawing of what happens. So we have a diameter that's not a diameter, a radius here. We know the radius should be half of the diameter, so our radius should be 60. All right, so the pencil's being weird. So here, that should be 64, and then we have 8 on top of that. So if we assume the ground is the x-axis and the center is on the y-axis, then I didn't draw the ground well. So then we know that the center is 0.72, and it's 72 because we have to add the 8 and the 64. So the center is 0.72. So the equation is x minus 0 squared plus y minus 72 squared equals 64 squared. So equals 64 squared. And 64 squared is 4,096. So that's it. There could be follow-up questions that involve you substituting in either a value of x or y to find the whatever information. So be on the lookout for that. For number two, we have a parabolic arch that is constructed. The arch is 6 feet wide at its base and 9 feet tall in the middle. And we need to find the exact height of the arch 1 foot from the base. So the arch is going to look something like this. And what we can assume, because we're drawing the diagram, is that we draw the parabola so that it's on the y-axis and is split evenly on both sides. So this is going to put our vertex here at 0, 9. And then since the base is 6 feet, that means that in either direction, we've moved 3 feet. So we have 3 in this direction, 3 to the right, and 3 to the left, which is going to make those coordinates 3, 0 and -3, 0. So if we write the basic equation of a parabola, that's going to be x minus 0 squared equals 4p times y minus 9. Then we need to find p so that we can actually write the equation of the parabola. So we're going to use one of these other points. Like we can use the 3, 0. We know that when x is 3, y should be 0. So we're going to have 3 squared equals 4p times 0 minus 9. So that's going to give us 9 equals -36p. And so -1/4 is equal to p. So our actual equation is x squared equals -1/4 times 4 is -1. So -1 times y minus 9. So if we're 1 foot away from the base, that means that you go 1 foot back here. So if we travel a distance of 1 back, that's going to make this coordinate 2, 0. Now we could also do the same thing on the other side where you move 1 from the left. So if that distance is 1, then this coordinate is -2, 0. So you're either using x equals -2 or y equals 2. It's the same thing because when we square it, we get 4. So we can really just say plus or minus 2 squared is equal to -1 times y minus 9. So that's going to give us 4 equals -y plus 9. And if we add y and subtract 4, we get y equals 5. So 1 foot from the base, the arch is 5 feet high. For number 3, we have a Wi-Fi antenna, and we're looking for where to place the antenna in this parabolic shaped antenna. And they tell us that the maximum reception occurs at the focus. Maximum reception occurs at the focus. And so the cross section is a parabola. So they tell us the parabola is 45 centimeters wide and 25 meters deep. So let's do that. So we have a parabola that looks something like this. And we know that this distance is 45 centimeters. So the whole distance is 45. And we're going to put this on the, we're going to put the endpoints of the antenna on the x-axis. So that's going to make our vertex 0, -25. And again, on either side of the y-axis, we have 22.5 centimeters. Also, that should be centimeters, not meters. So on either side of the axis, we have 22.5 centimeters. So our basic equation is x minus 0 squared equals 4p times y minus 25. And we're going to do what we did on the previous problem. We know that when x is 22.5, that y is 0. That should be squared. And let me grab my calculator. So 22.5 squared is 506.25. So 506.25 is equal to, I'm sorry, this should be plus 25 because we're doing minus -25. That should be plus. And so that's going to give us 100p. Again, the reason that we have a plus is because that's y minus -25. So my bad. And when we divide by 100, we're going to get 5.0625 is equal to p. Remember that p is the distance both the directrix and the focus are from the vertex. So since we're placing our antenna at the focus, this is where the antenna goes. And our answer is just, let's make a sentence. The antenna should be 5.0625 units away from the vertex. Ooh, messed up. From the vertex. And we mean up, not left or right. It should be up, but that's pretty obvious that we want to go up. All right, for number 4, we have an ellipse. So let's stretch that out. Okay. So what we know is that the semi-major axis of the ellipse is 1 astronomical unit. So if we draw a line from, we go all the way across the ellipse, then what we know is interior to this on the focus, so we'll say this is the center right here. That point is our center. So we'll say, all right, so I have to write in cursive so the thing doesn't actually delete. So this is our center. And they tell us at one focus, we have the sun. So here, this is the yellow dot is the sun. They tell us that one of the vertices is aphelion. So aphelion is over here, is farthest away from the sun. And then we have perihelion, and that is the vertex that's closest to the sun. And we know that the eccentricity is 0.0167. So we have this formula for eccentricity. Remember, the distance from the center to the focus is just c. And remember that c is, for an ellipse, the square root of the bigger denominator minus the smaller denominator and squared. And that the distance from the center to the vertex is a. Now, we actually know that a is 1 because they tell us that the length of the semi-major axis is 1, and the semi-major axis is just half of the major axis. So right there is your semi-major axis. So what we know is that 0.0167 is equal to c, why did I make a circle? Is equal to c divided by a. So a is 1. So easily we can solve for c. 0.0167, if we multiply by 1, is equal to c. So we already know that so c is our distance from the center to the focus. So this value is 0.0167. So if this distance is 1 from the sun to aphelion is equal to 0.0167 astronomical units plus 1 astronomical unit, which is 1.0167 astronomical units. And then the distance from the sun to perihelion is, all right, so the entire distance is 1, right? So we know all of this is 1. So that whole thing is a 1. I don't know why the 1 won't stay, but... And so the whole thing is 1. So we need to subtract 0.0167. So 1 minus 0.0167 is going to be 0.9833 astronomical units. All right. So that's it. We used an ellipse. So next is a whispering gallery. It's a thing that has this phenomenon where if two people are standing at the focus of an elliptical shaped room, one person can talk and it's going to sound, one person can whisper and it's going to sound as if the person speaking is speaking at full volume for the person that's standing at the other focus. So what we have to do is determine where the two people should stand to experience the whispering gallery phenomenon. And we know that the gallery is 200 feet wide and 75 feet tall in the middle. So we're just going to put this on the x-axis and have it bisected by the y-axis. So we get this. So we know that the distance from the x-axis to the top of the a gallery is going to be our minor axis. So we know that B equals 75. We know that A is the distance from the center to the end of the ellipse on our major axis. And so if the entire gallery is 200 feet wide, then since we're bisecting this distance is 100 feet. Okay, so that means that A equals 100. Remember, for an ellipse, the distance from the center to a focus is your C value. So C is going to equal the square root of 100 squared minus 75 squared, which is pretty sure, I can't be pretty sure. So 100 squared minus 75 squared is 4,375. So, under square root, so if we do that we get the square root, we get 66.1. So we know that this distance, let's put it out in red. We know this distance here is we'll erase this word center now. So we know this distance is 66.1, and that's true in both directions. So this is also 66.1. So 100 minus 66.1 is how far the people should stand from the outer walls. So 100 minus 66.1 is 33.9 feet from the outer walls. All right, and so for our last problem it's a drafting cooling tower for a nuclear silo. We know the tower is 450 feet wide at the base, 275 feet wide at the top, and 220 feet at the center, at the narrowest point. And that's 330 feet above the ground. And so we need to figure out how tall, so how tall is the drafting tower? So this is a hyperbola. So we're going to make the ground be where our 450 feet are. So this is our hyperbola. This is our XY axis, what I am drawing in red. So the center for our hyperbola is 0, and we're going to go up 330 feet. Again, it's 0 because we're, again, splitting the hyperbola in half vertically. So we have a center of 0, 330. And because the parabola opens left and right, we know that x should come first. So we're going to have x squared divided by, so A is the distance from the center to the vertex points. And if the entire thing is 220 feet in the middle, then the distance from here to here is 110 feet. So divided by 110 squared minus the y coordinate is y minus 330 squared, and we don't know B. It's tempting to believe that B is this 330 feet, but that's not true because we don't have symmetry to justify that on the other side. So what we have to do is actually calculate the value of B. We have to actually calculate it because for symmetry purposes, the silo is actually going to go down in the ground a little bit more if we were going to like completely make this accurate. So it would have to look more like that or something for us to know that. Anyway, so we're just going to put a b squared, and that should equal 1. Now the rest of this is algebra. It's some dense algebra, but it's still algebra. So we know on the ground, you would have to travel 225 feet in either direction from the center to get to the end of the silo, where the silo meets the ground. So those coordinates are 225, 0, and negative 225, excuse me, 0. So just choose one and substitute in for x and y. So we're going to have 225 squared divided by 110 squared minus y is 0, so minus negative 330 squared divided by b squared. And so let's put these values in the calculator. 225 divided by 110 squared is, I get 4 point, let's go with 4.2. So 4.2 minus 330 squared is who knows how much. Minus 108,900 divided by b squared equals 1. Okay, so from here, we're going to get negative 108,900, I'm sorry, divided by b squared equals negative 3.2. And then we're going to flip the b squared into negative 3.2. So negative 108,900 divided by negative 3.2 is equal to b squared. And that is, who knows, 34,031. So that's going to give us this equation of x squared divided by, so 110 squared is 12,100. So minus y minus 330 squared divided by, we said the number was 31.25. And that equals 1. And so now we have our equation. And to find the height of the silo, we just want to find the y coordinate here. So the top is 275 feet wide. That means that from the center, you would have to travel half of that, which is 137.5. So that's going to be 137.5 squared divided by 12,100 equals, we don't know y, so I'm sorry, not equals, minus, there should be a minus, my apologies. So minus y minus 330 squared divided by 34,031.25 equals 1. And so we're going to do that value. We get, let's see, 137.5 squared divided by 12,100 is 1.5625 minus y minus 330 squared divided by 34,031.25 equals 1. So when we subtract, so again, the rest of this is algebra. We're going to get 0.5625 because we subtract 1 and we move the y squared to the other side. So minus y minus 330 squared divided by 34,031.25. That equals the 0.5625. So again, we move this term over and we subtracted 1 from the 1.5625. So now we're going to multiply by the denominator. So 0.5625 times 34,031.25. I get 19,142.57 equals y minus 330 squared. So you would take the square root of both sides. and 19,142.57 to the 0.5. I get 138 point, let's go with 138.4. So 138.4 is equal to y minus 330. And so then you add 330 to both sides and you get 468.4 is equal to y. So the tower is 468.4 feet tall. All right. So that's going to conclude our video for applications of conic sections. The takeaway from this is we're just using the equations that we know for each conic section and solving for the missing information. Anytime we have to actually draw the shape, it's helpful to always center the conic section on the x-axis, the y-axis, or both. So like in this example, we centered the hyperbola on just the y-axis. For number 5, we also centered our ellipse on the y-axis. For number 4, we could have said we didn't need the actual equation, but we centered both the vertex and we centered the on the y and the x-axis. For number 3, we centered on the y-axis. Number 2, we centered on the y-axis. Number 8, we also centered on the y-axis. So that makes your calculations much easier. All right, see you all in class.